and passwords and stuff like that, so that you stop unnecessary accesses. So passwords are very important, but your passwords must not be weak. You need to provide good passwords. Passwords with names, surnames, phone, telephone numbers are bad passwords because anybody can guess them and have them. So you have to make sure that you get your passwords as complicated as possible. Combination of numbers, letters, blah blah blah, capital letters, small letters, all that. So some basic security practices is very important. When you configure in your Cisco devices, you configure service password encryption. That will help, and also your security password minimum length. This will tell how many characters. Okay, minimum length here is how many characters should a person enter before the switch can accept that password length. And also the login block for 120 seconds, 3 within 60 seconds. Now this is telling you that it will block attempts for 120 seconds if there are 3 failed login attempts within 60 seconds. So if you try to log in, you attack, you try again, it doesn't, you try again, the third time it will block you, and then it will block you this for 120 seconds if you try 3 attempts within 60 seconds at the same time. So this will help. So you can also go with SSH also. This will also help because Telnet is weak, because Telnet shows all passwords in plain text. So if you want all your passwords to be secure, and SSH will do that, because SSH does not only encrypt password, but you also make sure that your communication, when you are logging during this login period, your communications are secured. So that's it. So now I think we should be on the second to last part. So some commands also are very important, like the ping and the trace route. These are the 2 utilities that I use to check reachability on your network. So when you send a ping and then you receive exclamation, for instance, on your router or your switch, it's a good thing. That means you have a success. If you have an indication of a dot, that means the destination device is not responding. If you have a U unreachable, then that means your device itself from the first router where you send the ping from, that router is not functional, it's not working fine. So you can also use some extended pings. Also you can send a ping and then have it run for a long period, so that's fine. So we have some network baselines that can also be used, so to also trace and find about how to trace reachabilities and stuff like that. So who can interpret a trace route command? So when you send a request, you have a request timeout. It indicates that the router did not respond, so it is possible that there is a network failure or something like that. So when you send a ping, you want to know where the ping failed, you can use the trace route, because the trace route will tell you exactly where the problem lies. Okay, so that's why you have to use the trace route to do that. But for ping, it can give you information, but trace route will tell you exactly where you have the problem, and then you can get there and fix the problem. So we have the ARP whatever. So this ARP, like I said in our previous videos, it helps in mapping unknown MAC addresses to unknown IP address. So that's what it does. So you can use this ARP-D to know this address mapping. So we have the source CDP enable command. The CDP, what it does is that it provides neighbor relationship information between 2 Cisco devices. So if it is enabled, hackers can gain access through it by exploiting that weakness. So if you have this enabled, you have to make sure that you disable it between your devices. So show IP interface brief will show you brief information about your interfaces, their IP address, their status, and protocol configuration. So you have to look at that. Debug commands are also important to tell you real-time information about your network access or topology. So we have the terminal monitor command, also can be used to monitor to display log messages on a terminal or virtual console. So whatever happens, it will tell you exactly. So network troubleshooting is the last one. So 6 steps of troubleshooting methodology are that you identify the problem, establish theory of probable cause, test the theory to determine cause, establish a plan of action to resolve the problem, verify full system functionality, and also document findings and outcomes. So if you are first time, let's say level 1 technician, you can do all of these checkups, but as time goes on, you will need to have to provide some escalations. Okay, that means I cannot do this, I'll have to move it to my senior, and that is escalation. Okay, so Cisco iOS includes powerful tools, so you have them ping, traceroute. So, but those are the two top utilities that you can use to verify. So we have duplexes. Whenever you have a duplex mismatch between your switches, your network goes down. They will not communicate. So duplex, like I explained in my previous videos is the mode or the direction of communication. So you need to have your switches. When two switches are connecting, switches use full duplex. Your PCs and routers also run at full duplex, but a hub operator have duplex, so you have to be very careful with that. So when you are connecting two devices, you have to set the duplex as auto. Whenever you have a duplex mismatch, you have a network down. So we also have some IP address issues. Devices that are on the same network must be configured with the same IP range and the same subnet mask and the same default gateway, but otherwise they will not communicate. A default gateway is used by devices to communicate out of the network. So if a device does not have a default gateway, a proper default gateway, it will not be able to communicate. So that's the end of the chapter. So I hope to see you guys in my next video, and that will be semester 2. So I'll tell you guys when to do the exam. Bye bye.